Hi everybody, welcome to video number 20, Dark Object Subtraction in ENVI. In the last video, we learned how to clip a Landsat image in ENVI. And ultimately we're going to use this Landsat image to do what's called spectral mixing. And so in order to do spectral mixing, we need to make sure that we're getting really clean reflectance spectra from whatever material is on the ground. And part of doing that means stripping off any backscattered atmospheric component. And that backscattered atmospheric component of radiation is called path radiance. So in this video, I want to talk about what path radiance is, and then how dark object subtraction is used to remove it, and then show you how to actually perform dark object subtraction in ENVI. So to start, let's go through a review of how radiant energy gets from the sun to the satellite sensor where the image is collected. So it's emitted from the sun as a radiant flux in watts. Some of those watts make it down and hit a 1 meter squared patch of ground, and that's called the irradiance, E. Depending on the reflectivity of the surface, some fraction of that irradiance is reflected back and becomes what's called outgoing radiance, or L. And that's just equal to the reflectivity times the irradiance times the transmissivity of the atmosphere divided by 2 pi, recognizing that a Lambertian surface will radiate the energy evenly into a 2 pi hemisphere above the surface. In any event, that outgoing radiance is eventually measured by the satellite sensor. And we're going to call that measured radiance L total. But notice that in addition to the outgoing radiance that was reflected off the surface, we're actually detecting an additional component, and that's called the path radiance. This is light that never made it to the surface, but was actually scattered in the atmosphere, some of it scattered back to the sensor. So if we want to ultimately calculate reflectance, the first step is actually to remove this path radiance so we can get a clean estimate of L, or the outgoing radiance. So to do that, just recognize that measured radiance equals the outgoing radiance plus the path radiance, and we can get that outgoing radiance L just by subtracting off the path radiance from the total measured radiance. And dark object subtraction is a technique that does that. And the way it does it is by simply finding the darkest pixel in the image and assuming that that pixel isn't reflecting any light at all back to the camera, and that any light measured from that darkest pixel must all be coming from path radiance. We then subtract off the digital number value of that pixel from all the other pixels, assuming that that path radiance is the same for all the pixels. So in summary, we'll find the darkest pixel and subtract that value off all the other pixels. So let's learn how to do this in ENVI. So I've got my ENVI project loaded up here. I've got my 8 Landsat bands, which we've already clipped. And importantly, we've clipped off the outer edges of the Landsat band where there were dark pixels associated with no data values. So we know the darkest pixel in this image is actually going to be some element of the image surface and not just the edge of the actual picture. So to find the dark object subtraction tool, it's under radiometric correction, dark subtraction, and we'll need to do this one band at a time. So I'm going to pick B1, the first Landsat band, do the entire scene. ENVI offers me a few different ways to do dark object subtraction. The band minimum option is the approach I just described, or I could specify a region of interest and have ENVI extract the digital number of that region from all the pixels. Or I could just specify the value a priori. So we're going to go with the band minimum approach, and all I need to do is simply choose an output file name, and I'll put this in my Landsat folder, call it B1 clip DOS for dark object subtraction, the .tiff extension, hit OK, and voila. We're not seeing a big change in the appearance of this image because there wasn't a lot of clouds or aerosols in the air that were causing a lot of path radiance. So it didn't have a huge effect on this image, but this can be very important for images, particularly on hazy days or hazy conditions. So to remind you, we talked about what is path radiance, how we can use dark object subtraction to correct for it, and how to do dark object subtraction in ENVI. Tune in for our next video, video number 21, on how to do a radiometric correction in ENVI. Thanks for listening.